All right, so exponential functions. I went ahead and gave you a handout there, and it basically defines what an exponential function is. Okay, an exponential is a function that can be described by an equation of the form y equals ab to the x. Now, what a lot of people don't understand or realize is that this is actually y equals a times b to the x. Okay, and a lot of people think it's ab to the x power. It's not. A is by itself. A is on an island by itself. B to the x is on another island. Okay, A cannot be 0 because if A is 0, what do you know about the whole function?
It's 0.
It's 0. Okay, B has to be bigger than 0, which means B has to be
1.
positive. Right, it has to be a positive number, and B can't equal 1.
Oh.
Okay, so these are some characteristics that the exponential function has to follow. So an example, 2 times 3 to the x. So notice how they have that written. Okay, I want you to understand this is not the same thing. You can't multiply the 2 and the 3. It's like a couple. We've got Valentine's Day coming up. We're going to feel the love. Okay, this is a couple. 1, 2. Okay, you can't combine those. All right, here I've got y equals 4 to the x. What is a in that problem? 1. So this is really like 1 times 4 to the x. Okay, this is y equals 1/2 to the x. So this is y equals 1 times 1/2 to the x. Okay, so 2 distinct terms. So let's go ahead and look at what we're going to be doing here. We're going to be graphing. Now notice what it says. It says graph y equals 3 to the x power. Find the y-intercept and state the domain of the range. Now, very first, what we're going to do is we're going to start with a t-chart. Okay, and we're going to find values. Now, good rule of thumb is to start with numbers around 0. So a good rule of thumb that we could do is we could do -2, -1, 0, 1, and 2. Since this is our first graph, we're going to use a little bit more values than we would normally use, just so that you can kind of see how it looks like. Okay, so I'm going to plug in -2 in for x. So what this means is I've got 3 to the -2 power. Do we remember what that negative means? Turn into the denominator, so it should be 1 over 3 squared, which is 1/9. So a really, 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 really small number. It's actually 0.11. Let's do 3 to the negative first. What will this be? 1/3, which is once again a really small number, 0.33 repeating. So this will be 3 to the 0 power. What is anything to the 0 power?
1.
Yes, good job. Okay, equals 1. Next one will be 3 to the first. What's 3 to the first equal? 3. Next one will be 3 to the, which is 9. So now I need to plot those. So I'm going to start with -2 and 1/9. That's a pretty small number, so we're just going to put it like right here. Okay, biggest thing, it does not touch the axis. Where will the next one be? About 1/3 of the way up, so about right here. Where's the next one?
1.
Yep, up at 1. At 1, where's it going to be? 3. And at 2, where's it going to be? 9. So a little bit about what this graph looks like. I'm going to go ahead and draw it in, and then you can kind of see and you can kind of mimic on your paper. Okay. A little bit about the exponential graph. It does not touch that x-axis, ever. So you see this line right here, and even I'll color it. Okay? Okay, that pink line, you never touch with your line on that exponential function. Okay? It's kind of like an invisible boundary. For those of you that take future math, what we'll do is we'll talk about what these invisible boundaries are called. They've actually got a real cool name. They're called an asymptote. Okay, but that's what an exponential function looks like. Now, will it always look like this? No, it may go the other direction. Okay, it may go something like this. Okay, but it will generally have the characteristic of always getting big, steep. All right, so let's go ahead and look at another one. I've got another one for you there. Graph y equals 1/3 1/3 to the x power. Now on this one, we might not have to go all the way to -2. We might only have to do -1, 0, and 1, since you kind of already know what it's going to look like. Okay. So now I've got 1/3 to the -1. Remember, that means we flip it, the -1 does. So this actually means 3. Yep, 1/3 to the 0 power, and that means 1. And then this is 1/3 to the first, which is 1/3. So let's plot those and see what we're left with. So -1 and up 3. Okay? 0 and 1. So what's this one going to do? It's going to curve down. It's going to curve the other direction. Now, if we would have went all the way up to -2, we would have found it went all the way, up to 9. Okay, but once again, it does not touch that axis. And there you go. So far, do you think you can handle the graphing? Because we've got a few more things we need to discover. Okay, let's go back to that first slide. This one says find the y-intercept. The y-intercept is where it intersects the y-axis. So the y-intercept here, what is the y-intercept? 1. That's where it intersects the y-axis. That's right here, folks. It says state the domain and the range. We've talked a little bit about domain and range. I will tell you the domain here is always going to be all reals. It will always be all reals. So you should be able to get that right. Everyone, all reals. The range, on the other hand, is remember just the y's. Okay, so what can you tell me about the y's we're going to get here? You're only going to get positives, right? So how we're going to write that? Y is greater than 0. Because remember that greater than 0 always meant positive. So domain is always all reals. Okay, so let's look at the next one. Okay, we've already graphed this, remember. What's my y-intercept going to be? 1. Okay, that's right here. All right, what's the domain? All reals. What's the range? Y is greater than 0. Okay? I won't say always. Okay? The domain is going to always be pretty much all reals. The range might change. So I want you to go ahead and we're going to look at this one. Okay? We're going to look at 3 values here. And the 3 values we're going to look at are -1, 0, and 1. Okay. Now we're going to try to do this one all in one step. So, -5 to the -1st plus 1, or plus 2. Okay, now what does this 5 to the -1st mean?
It's going to be
1/5, and then I'm going to attach the negative. Okay, so it'll be 1/5, that's what 5 to the -1 is, so negative, and I'm going to add 2 to that. So what does that equal? 1 4/5, or you could put 1.8. It doesn't really matter. You could have a decimal here because all we're looking at is points. Remember where they're at. So I'm at -1 and then 1 4/5. So probably about right there. Okay. All right, the next one. If I plug in 0, I get -5 to the 0 power plus 2. Okay, so -5 to the 0 power is actually a -1, folks. Plus 2 is 1. So at 0, it is at 1. Okay, so this one will be -5 to the 1st power plus 2. What is negative 5 to the first? Negative 5 plus 2 is negative 3. So I'm at 1, negative 3. We're going to do number 2 just because it's kind of weird right now. We kind of don't know what we're going to get. So let's plug in the number 2. Now, if you're a little confused what you do here, you always do the power first and then attach the negative. Yep. So what do you get then? Negative 23, and I think you should have room to go all the way to negative 23.
Would it be,
Unlisted?
so even though it's negative 5 to the second, you would attach the negative afterwards, and it wouldn't be the same as negative 5 times negative
Order
5?
operations always states that you do exponents first. Okay? This negative out front is actually multiplication by negative 1. The only way you would have been correct in your statement is if it would have looked like this at the very top with the parentheses around, but it doesn't. Okay, so now, do we kind of see what the graph is going to do? It's going to go down. So let's say the y-intercept is what?
1,
1. Got that 1. What's the domain going to be?
all real numbers.
All real numbers. Good. Now the range. Let's think about things.
How did you find the range on
The range is just your y values, so it's like where your graph is shaded. Okay? So now let's look at this. What was this value up here? That was 1 and what?
4/5.
4/5. 1 and 4/5 is close to what value?
2.
2. Let's look in the problem. Do you think that 2 has any sort of importance whatsoever?
That's where that's like we can't go back.
This is kind of like the boundary. Okay? Notice where 2 is at. 2's up here. And that's why you've got to kind of look at both. What can you tell me about the graph? Is it going to be bigger than 2 or less than 2? Less than 2. So how am I going to write that?
Why?
Y is less than 2. So it's kind of one of those. You have to look at your graph, look at then your equation, and kind of do the two together. All right, next one, exponential growth functions. What does it mean when something grows? It gets bigger. And actually, one of the neat things about this is the Centers for Disease Control, they actually look at these exponential growth models when they look and track diseases. Okay, has anybody seen the movie Outbreak? Because they talk about how this disease is going to infect and basically kill off a population. And so that's kind of one of those neat things. So this is exponential growth. Not neat in this fact. Anyway, you guys get it. Exponential decay means what?
It disappears.
It gets smaller. And so this is used a lot with radioactive elements, especially with nuclear rods and that with half-lives, except for the half-lives are so long. I mean, we're talking thousands and thousands, millions of years. Okay, but that's where the exponential decay comes in. All right, so that's what they look like. Biggest thing, they have a few characteristics. Okay, the first characteristic you're going to notice here is that B is bigger than 1. And that's got to make sense because B's got to get bigger, right? Here, B is between 0 and positive 1. So, in other words, B is what type of number?
It's a
Decimal.
It's a decimal or a
Fraction.
fraction. Okay, because it's got to be between 0 and 1. All right, so it says determine whether the set of data shown displays exponential behavior. Write yes or no. Explain why or why not. So what we're going to do here, if it displays exponential behavior, it's going to increase the same amount every time. So this one, do I increase the same amount every time?
Yes.
I'm going up by what?
5.
5. Do I
Yep.
decrease the same amount every time?
No.
What do you do here?
No.
Go down by
Minus
5.
30.
You go down by a half. You go down by a half. Do you do the same thing here? What do you do here? Down by a half. You have to check every one. What do you do here? Down by a half. Or another way to view it, you divide by 2. So that might make better sense if you want to put divided by 2, divided by 2, divided by 2. So does this display exponential behavior? Yes. Okay, why or why not? It decreases the same amount every time. Okay, it's a proportional amount every time. And so where this is going to lead us is into sequences, which is, love sequences, they're great. So let's look at this next one and we're about done. Okay, what do? You go up by 3s. And what do you go on this one? Up by 4s. So real quick, I'm going to give you 30 seconds. Do you think this is an exponential function? Yes or no? 30 seconds. Go. So talk amongst your group. I'm going to get you okay, 15. Okay, 5. All right, that group. Does it display exponentially?
Yeah.
Shh. That group.
I knew that was gonna happen.
no.
What did we do on the last problem?
Combine.
You multiplied or divided. What am I doing here?
Adding.
Adding. That is not an exponential growth or decay. Exponential growth or decay only deals with multiplication. Okay, so even though these go up by 4, they are not multiplied by the same number. So that's the important thing to look at with exponential growth and decay. All right, let's go ahead and turn to page 427 in your book. Let's talk about your assignment. Okay. On page 427 and 428, 10 through 18 evens. Those are just like the graphs. If you want graph paper, it's located in the top drawer. 20 through 29 all. So 20 is kind of a word problem there. I think you can solve it. You should be fine. 21 through 24 is like the last ones we looked at. And then 27 through 29. That's why I wanted you to look here. It says identify each function as linear, exponential, or neither. What does linear mean? Line, the root word. So when you see linear, that means it's a line. Okay. Exponential, we looked at. Those are exactly what we looked at today. Okay, and neither means it's not linear or exponential. Alrighty, so for tomorrow, page 427, 428, 10 through 18 evens, and 20 through 29 all.